So this is Maths KA4 2025. So we've got question 11 here. We've got temperature theta of a cup of coffee as it cools is modelled by this equation. Time t in minutes after the coffee was prepared. State the starting temperature. So that'll be when t is 0. So theta is 22 plus 64 e to the minus 3 over 32 times 0. 22 plus 64 times e to the 0. Remember, it's just the e that's to the power 0, so that's just going to become 22 plus 64, or 86 degrees C. You didn't need the degrees C for the mark. Okay. Part B, find the rate. I can use highlighters on here. Find the rate at which the coffee is cooling at 10 minutes. Now, the second you see rate, we need to differentiate. So the 22 is going to disappear. We're going to times that minus 3 over 32 down, but the rest stays the same. So that's going to be minus 6e to the minus 3 over 32t. We know t is 10, so d theta by dt is minus 6e minus 3 over 32 times 10, which is minus 6e to minus 3 over 32 times 10 minus 2.435. Now it's asking for the rate that it's cooling. So the rate of cooling is 2.35 degrees C per min. Okay. Part C, determine according to the model the length of time that the temperature of the coffee is between 40 and 60. So if you find the time that it's 60, find the time that it's 40, do the difference between them. So theta is 60. So at 60 is 22 plus e to the minus 3 over 32t, or 38 is e to the minus 3 over 32t. Have I lost the number? Yes, I have. Oh no. And that's how easy mistakes are to make in a test. E to the minus 3 over 32t, 64 e to the minus 3 over 32t. Divide by the 64, so 19 over 32 is e to the minus 3 over 32t. So we've got ln, 19 over 32 is minus 3 over 32t, and t is minus 32 ln 19 over 32 over 3. Let's do the same for 40. So it's actually really similar working. It's the same working. So 18, 64 e to the minus 3 over 32t, 9 over 32 e to the minus 3 over 32t, ln 9 over 32 is minus 3 over 32t, and that t will be minus 32 ln 9 over 32 over 3. So the difference is going to be bigger takes smaller, I guess, is going to give us a nicer number. And that comes out to be, I'll have to, hang on. Oh, that's going to be minus that. Sign error coming. ln 19 over 32 struggling to see my calculator, sorry. 9 over 32 7.97. We need it to the nearest second. So it's going to be 7 mins. So take 7 times by 60. 58 seconds. We have to squish parts D and E in. So D, evaluate 2 hours after it's prepared, the cup is 20.8. Evaluate the model. Well, if we look at this equation, if you drew it, this 22 shifts the whole graph up 22. So it shifts it from having an asymptote that's flat to having one that's at 22. Meaning, according to the model, the min temp is 22 degrees C. Pour as it got cooler. And 3, an insulated cup designed to decrease the rate. So, how should we change the model? Well, it's this number here. So when we times it down, that is going to determine the rate. So if we make that a number closer to 0, a smaller magnitude, say -1/32, we'll get a smaller number here. So the rate will always be lower. So decrease the magnitude of the power. And that is this question done.